So today we're going to continue with systems of linear inequalities. We're really continuing with systems, right? That's what this unit's all about, is solving these system of equations. And up until today, we found points of intersection. So if we had a graph, for example, and then we had two lines that intersect at some point, that point of intersection, whoops, that was a little more than I wanted to do. That point of intersection, that x and y coordinate where they meet, that's our solution to the system, right? If they meet. They don't always meet. So today we're working on systems of inequalities. And so what that means is, for us anyway, there could be an infinite number of solutions. And the only way to solve these is graphically. And so I want you to think back, right? If we have x is greater than or equal to 4, then there's an infinite number of values that could be x, right? So x could be 4, that's true. X could be 5, that also gives us a true statement here. 5 is bigger than 4. And for x is equal to 4, if 4 is greater than or equal to 4, so either one of those would satisfy. It's kind of very like systematic the way that we're going to do these, and it's all going to rely on our ability to graph functions. And so, these are not too terrible. We have to be careful about a couple things. Maybe use this space right here. We want to remember if we have a greater than or less than symbol, we're going to get a dotted line. And that looks like that would go along if we were to write set notation, which we won't be able to with this. That would be parentheses, right? X comma some y. Now, again, that's not going to work and for this. And if we have less than or equal to, greater than or equal to, that's a solid line. And then we're going to have to shade to show where we have a solution. And that just kind of goes back to our number line and go back to our x is greater than or equal to 4. If I have a number line and I have 4 on that number line at some point, right? And so x is greater than, that would be a big circle, and then we would shade in that line, and it's all the values greater than or equal to 4. So we're going to do some shading today as well. So let's start off like step one, really, when we're graphing these things, is we want to put it in standard form. So we want it to be in y equals, so we're going to put in y equals mx plus b form. And so I'm going to label these just to kind of stay organized a little bit. We're going to call this equation 1, and we will call this guy equation 2. And so that's the first step. Let's take equation 1. I'm just going to copy it and move it over here so I have a little bit of room. I'm going to take equation number 1, and so we have y minus 3 is less than or equal to x. And we're going to solve this thing for the y value. We want it to be, we want y all by itself. So I'm going to add 3 to both sides. And we end up with y is equal to, whoops, y is less than or equal to, less than or equal to, I'm going to put the x in front, and then we have plus 3. And so just kind of looking at this, we know that my slope, m, is 1, and my b value is 3. And so that's going to help me graph this. I'm going to stick with the blue. So come over to our graph, figure out where 3 is. And so it looks like 1, 2, 3. There's my y-intercept. It's my b value. And then my slope is 1. That means we're going to have a rise of 1, and we're going to go 1 to the right. So up 1, right 1, up 1, right 1. And that's going to be hopefully pretty straightforward for us. So let's just connect the dots. It's going to look like this. Ooh, is it not going to let me? I didn't like that. All right. So no on the line. That's kind of interesting that it can't get that. So there's one line. I highly suggest you guys use rulers if you have it. There's our second line. What we want to do next is we want to figure out where we're shading. And we did have a less than or equal sign, so my line is a solid line, not a dotted line. It's a solid line. We should shade this, and I would go with my simplified equation, right? I would go with y is less than or equal to x plus 3. The test point that I would pick to see where we want to shade. Because we don't go through the origin, I would pick 0, 0, and we just plug these in for my x and my y value and see if we get a true statement or a false statement. So my y value is 0. That's less than or equal to 0 plus 3. And so 0 is less than or equal to 3. That's true. So we're going to shade below this line, but we're not going to go like crazy and shade this whole thing in like kind of hardcore. We want to just shade a little bit, right? Just very little bit. We don't want to go and like scribble this whole thing in because we're going to have to do some more shading on this. So we kind of have an idea like which way my shading's going. And now we're going to move on to equation 2. And so I'm just going to copy it here again. We have 2x plus y is greater than or equal to negative 5. So greater than or equal to, that's going to also be a solid line when we graph. So I need to get y by itself. I'm going to subtract 2x from both sides. And that's going to look like, that's going to give us y is greater than or equal to, I'm going to put 2x first, my negative 2x minus 5. And so we're going to graph this the same way. We're going to come over to my y-intercept of negative 5. Let's see, 1, 2, 3, 4, 5. There's my y-intercept. And now my slope is negative. So my slope is going to go down 2, 1, 2 to the right 1. Down 1, 2 to the right 1. And I'm going to go up and left, up and left. And we're going to try and connect these dots. If you have a ruler, this is going to be much easier. So there's my line. So we're trying to find really the overlapping region, right? So I'm going to do the same thing for my second equation, equation number 2. I'm going to use a test point of 0, 0. Now, if it goes through the origin, if it goes through 0, 0, you can't use 0, 0 because that won't give us any new information. So what we want to do, and if it does go through the origin like that, if it goes through 0, 0, is I would just pick like 0, 1. So I'd come over 1 and pick that, or one, up 1. So that would be 0, 1, or we could go left 1, negative 1, 0, down 1, whatever, it doesn't matter. I try and pick the easiest numbers I can to make this easy on myself. So our test point is going to be 0, 0. We get 0 is greater than or equal to, so negative 2 times 0, I'm going to write it, negative 2 times 0 minus 5. So that becomes 0 is greater than or equal to, negative 2 times 0 is 0, and 0 minus 5 is negative 5. So is 0, think about our number line, is 0 greater than negative 5? And that also gives us a true statement. So what that means is, here's my test point, making it giant just to make sure you can see it. There's my test point. My test point was true, so I'm shading on the same side of the line as that test point. The thing that I want you to remember is our solution set is where my shading overlaps. And so let's take a look at this guy. And I'm going to shade the solution region, I guess, with that blue. So here in this region, we can see that both sets of shading are true. And so we're just going to shade that out. Use my highlighter, I'll make it easy. And that is our solution set. I want to talk a little bit more about some stuff that's going on. So what this means is that I can pick any coordinate point in this shaded region and it will work for both inequalities. It will give me a true statement. So like I'm going to pick the point, let's be silly, let's pick the point 10, 10. So I'm going to pick the point 10, 10, and we can test that in both inequalities. We can go back to our original inequalities to get our test point. So if I take my original equation number 1, I'm using this equation number 1, I'm going to plug in 10, 10 for my x and my y value. And I plug that into equation number 1, we get 10 minus 3 is less than or equal to 10. And so 7 is less than or equal to 10. That works. So that satisfies that first equation, right? That first inequality. I'm going to do it for the second inequality. I'm going to do that for number 2. I'm going to do the same test point, 10 comma, not 10 comma 0, 10 comma 10. And that's going to be for equation number 2. So I'm turning those x's and the y's into 10s. So we get 2 times 10 plus 10 is greater than or equal to -5. And I don't even need to do any more work than this, because I know that 2 times 10 is a positive number, and we're going to add another positive number to it, and that has to be greater than -5. So we know the solution set works. Anything in this shaded region satisfies the system of linear inequalities, meaning we can plug in the coordinate point, I could plug in this coordinate point, that coordinate point, any coordinate point I want in the shaded region. I could even plug in that coordinate point where the two lines intersect right there. I made that giant on purpose so you could see it. And it's going to work for both inequalities. It's going to give us a true statement. We could also pick a coordinate point, and I think this is it's going to ask you in the homework to pick some non-solutions, which always seems kind of silly to me, but that's what we're going to pick. I could pick this point right there. I don't know what that coordinate point is. -1, 2, 3, 4, 5. 1, 2, 3, 4. Well, I got lucky. So non-solution, -5, -5. Now, -5, -5, my coordinate point would work for my blue line. That would work for y is less than or equal to x plus 3, but it doesn't work for my green line, so it's not a solution, right? I could pick any coordinate point I want. That's one. I'll let you pick one. For example 2, because I don't know that I want this video to be an hour long, I think I want you to pause the video, and I want you to solve equation number 1, and I want you to solve equation number 2 for y, and then we'll pick up from there. And so I'll work this out while you guys are working it out, and then we'll move on. All right, so checking back in with you guys. Equation number 2 was already solved. I just rewrote it so that it could all be down here on the same line. So it was already solved for y, so we didn't need to do much work. I want to point a couple of things out before we go too far ahead. So it looks like that is a greater than or equal sign, so that's a solid line. Equation number 1 has a strictly less than, so it's a strict inequality. So that's going to be a dotted line. Don't forget to make that a dotted line. Let's start with equation number 1, graphing. And I guess, and maybe we should point out, there's a couple other things that are going on here. I noticed when I was solving that they both have the same slope. And so think about what that means if they have the same slope and what's going to happen. Okay, so let's graph equation number 1, and my y-intercept is at 2, so I'm going to come over 1, 2, making that dot really big just to make sure you guys can see it. And my slope is -2/3. That means I'm going to go down 2 and to the right 3, down 2 to the right 3. And so you can graph it, they're linear, you can graph it with one coordinate point, or two coordinate points, excuse me. I like to do I like to do 3 coordinate points just to make sure that I didn't make a mistake when I graph. If you graphed 2 coordinate points and then your third one, and you don't end up with this nice straight line when you go through your coordinate points, you know you got a problem. It looks like I missed them totally. Let's try this again. So let's see, it looks like we could start right here, go that way. Yeah, I wish this program had a ruler function where I could put a virtual ruler on the screen and move it around, and so that'd be pretty good. I missed it a little bit there too. That's okay. So again, I'm going to try my favorite test point in the world, which would be 0, 0. Makes life easy. So when I do my 0, 0, I want to see what kind of statement I get. I plug in 0 for y, and we get 0 is less than. So -2/3 times 0 plus 2, and so we get 0 is less than, let's see, -2/3 times 0 is 0, plus 2 is 2. And we get a true statement. So this is true. We're going to shade below it. Again, I'm not going to go crazy. Just going to shade a little bit so we know which way my shading is going to go. And then we're going to turn around. We're going to graph equation number 2. And I see my y-intercept is at 5. So 1, 2, 3, 4, 5. Come over to 5. My slope is the same. We're going to go down 1, 2 over 3, down 2 over 3. I get a couple lines, a couple dots, and let's graph this guy. Let's see what we get. That looks pretty good right there. Okay. Well, I'm off a little bit. 1, 2. That's okay. My blue line is the one that's off a little bit, actually. Okay, because I missed right there. That's okay. So we should hopefully know a couple of things. Let's get our test point. Again, we're going to do 0, 0 as our test point. So we go 0 is greater than or equal to, so negative 2/3 times 0 is 0. So I'm not even going to write that. And that's plus 5 is going to give us 5. And so 0, here's what we end up with. 0 is greater than or equal to 5. That is false. And our test point was over at 0, 0. We end up with that false test point, right? That means we're shading on the other side of the line. So what this means is that there is no solution to this system of linear inequalities. And again, my line's a little bit crooked right there. It was not that big of a deal. And so there are no solutions.